that is units and the measurement. In this units and dimension, we have a very small concepts here. Maybe they are going to ask for 5 to 6 marks for this coming quarterly test. Students, you know that what is a quantity? The quantity is the one which can be measured very accurately. To measure the quantity, we are going to represent that quantity with the standard, precise, accepted from internationally, that is what we called as a unit. So unit is just a representation of the standard, precise, which is accepted from the internationally system, that is considered as the unit. Example, from the system of international, for mass we are going to denote with kg, for length we are going to denote with meter, for the time we are going to denote with second. So these are the units which are internationally accepted from the system. That standard, precise, accepted from the system of international is called as the unit. So these are called the units. So what is the unit of mass? Kg. What is the unit of mass? Length. What is the unit of time? Second. And these are the three quantities which never depend on other quantities. So only we are going to consider as a fundamental quantities. So what are fundamental quantities, students? Fundamental quantities are the one which does not depend on any other quantities. They are considered as the fundamental quantities. Which are the three fundamental quantities? Mass, length, the time. In SI system, we are going to denote this mass with kg, length with meter, time with second. There is one more system before the SI system. You can consider that as MKS system also, meter, kilogram, second. In CGS system, it is centimeter, gram, second. So this is gram, this is centimeter, this is second. There is one more system called FPS, that is pound, feet, and the second. So these are the three systems of units we have. One is called the MKS system, CGS system, and the FPS system. After introducing these three quantities, that is mass, length, and the time, they have introduced some more quantities like current, temperature, amount of substance, and luminosity. So these are the four additional quantity added to these three fundamental quantities, which is already mentioned in the MKS system. Addition to the MKS system, we have introduced other four quantities. This we considered in the SI system. So SI system means it is an international system of units. International system of units. In this international system of units, we have seven quantities. Mass, length, time, current, temperature, amount of substance, luminosity. Can you tell me what is the unit for mass? It is kg. For length, it is meter. For time, it is second. For current, it is ampere. For temperature, it is Kelvin. For amount of substance, it is mole. For luminous intensity, it is candela, denoted by the symbol CD. So students, how many quantities are there in SI system? There are 7 fundamental quantities in SI system. You can name the 7 fundamental quantities: mass, length, time, current, temperature, amount of substance, and the luminosity. Addition to this, there will be two another important quantities. They are considered as a supplementary quantities. Name the two supplementary quantities, students. One is called as the plane angle. The second one is called as the solid angle. So plane angle is going to be measured with the radian. The solid angle, which is the 3 dimension, is going to be measured with the steradian. Steradian, SR. So these are the two supplementary quantities. So there will be 7 fundamental quantities and 2 supplementary quantities in the system of international units. Okay. Now, let me know what is the dimension. What is the dimension? Now, if I give the derived quantities, students, what is the meaning of derived quantities? Derived quantities are the one which depends on fundamental quantities. Derived quantities depend on fundamental quantities. When it depends on fundamental quantities, we have to raise the power. We have to raise the power for fundamental quantities. Whatever the power you are raising for the fundamental quantities to get a derived quantity, that is called as the dimension. So what is dimension, students? Dimension is the one where we are raising the powers for the fundamental quantities to get the derived quantities. Students, they may ask, what is dimension? What is dimension? It is the power raised to which quantities? To fundamental quantities. The power raised to the fundamental quantities to get the given physical quantity are called as the dimensions of the derived quantities. If you want an example, a very simple example I can take. What is velocity? Velocity is defined as distance by time, right? What is distance by time? Distance is measured with length. Time is represented with the t. So I will keep L1 as it is. If I take t power 1 to the numerator, it becomes what? T power minus 1. So no m term. So I can write m power 0. M power 0, L power 1, T power minus 1. This is the dimensional formula for which quantity? Velocity. So what is velocity? Velocity dimensional formula is m0, L1, T minus 1. This is how we are going to denote the dimensional formula for velocity. Yeah. Now I will give the basic quantities. For this quantities, you have to write the dimensional formula. Quantities, you have to write the definition, then you have to write the dimensional formula, students. some few quantities I am going to give now. First one, can you tell me what is the dimensional formula for density? Density is represented with mass by volume. Mass means m power 1. Volume means length into breadth into height, L cube. If I take L cube to the numerator, it becomes what? L power minus 3. No T term. So T0. So what's the dimensional formula for density? M1 L power minus 3 T power 0. Can you tell me the dimensional formula for velocity? What's the definition for velocity?
Displacement method.
The distance by the time. Distance is L. Time is T power minus 1. If I write it in the numerator, no M term. So M0 L1 T minus 1. Can you tell me what is acceleration? Acceleration is velocity by time. So velocity is m0 L1 T minus 1. But in the denominator, we have a time. So if I take that term to the numerator, it becomes T minus 2. So what's the dimensional formula for acceleration? m0 L1 T minus 2. Can you tell me what is the dimensional formula for force? Definition for force is mass into acceleration. Mass is m1. Acceleration, we have a dimensional formula here, L1 T minus 2. So what's the dimensional formula for force? M1 L1 T minus 2. What is work? The other name for work is energy. And also we can write it for torque. Or you can also say couple. All these quantities are same. Work is nothing but the force into distance. What is force? M1 L1 T minus 2. Distance means into L. So it becomes L power 2. So what's the dimensional formula for work or energy or torque or a couple? M1 L2 T minus 2. Students, if I ask the question, what's the dimensional, name the quantities having the same dimensional formula. What will you answer? Name the quantities having same dimensional formula. Name the quantities having same dimensional formula. Work is equal to force into distance. Energy is force into distance. Torque is force into distance. Couple is force into distance. So name the quantities having same dimensional formula means work, energy, torque, and the couple. For any quantities, if you know the definition, you can write the dimensional formula, students. But it is very tough to remember the dimensional formula for all the quantities right now. But after completing all the chapters in physics, if you know the definitions and the formula, you can write the dimensional formula easily. Now, I'm going to give one more this thing. I know what is the gravitational force, students. What is gravitational force? F is equal to G into M1, M2 divided by D squared. What is this G called?
Gravity.
G is a constant called the gravitational constant. Now, can you tell me what is the gravitational constant dimensional formula? What's the dimensional formula for the gravitational constant? From this equation, you know that the gravitational constant is F into D squared divided by M1, M2. So what is force? Dimensional formula for force is m1 L1 T minus 2. Distance squared means L squared. Mass into mass means m power 2. So if I take this m power 2 to the numerator, it becomes m power minus 2. Already 1 is there. So m power minus 1, L power 3, 1 into 2, and T power minus 2. So can you tell me what is the dimensional formula for gravitational constant? M minus 1, L power 3, T power minus 2. And you know what is momentum, no students? What's the formula for momentum?
M into A.
Mass into velocity. Very good. Can you put the dimensional formula for this? M1 for velocity it is L1 T minus 2, right? So this is the dimensional formula for the momentum. Now, can you know what is the impulse which we have discussed in the last session? What is impulse? What is impulse?
Force into time.
Very good. Put the dimensional formula for force. For velocity, it is L1 T minus 1. Time is T. So M1 L1 T power minus 1. Look at the dimensional formula for momentum and impulse. What's the dimensional formula for momentum and impulse? Is it same or different?
Same, sir.
It is same, right?
Yes, sir.
So name the quantities having same dimensional formula means you can add up this also. Momentum and impulse. Momentum and impulse is also the quantities having the same dimensional formula. Next concept. Principle of homogeneity. What is the principle of homogeneity? Now, can you tell me what is the value of 2 plus 1? What's the value of 2 plus 1?
3, sir.
3. Can you tell me what is 2 kg plus 1 kg?
3 kg.
3 kg. Can you tell me what is 2 meter plus 1 meter?
3 meters.
3 meter.
Okay. Then can you tell me what is 2 kg plus 1 meter?
We can't add them, sir.
We cannot add these two quantities. Very good. Why we can't add these two quantities? Because these two are representing the different quantities. If the different quantities are there, we can't add. So we can add the quantities, we can equate the quantities, we can subtract the quantities only if the dimensions are same. Only if the dimensions are same. That is what we called as the principle of homogeneity. So according to the principle of homogeneity, we can add or we can subtract or we can equate the quantities. We can equate the quantities only if they are what? Same dimensions. If they have the same dimensions, then only we can add or we can subtract or we can equate. Okay. I'll give one simple example, students. I'm going to give the force F is equal to A into T. A is some constant. T is the time. F is the force. Can you find what is the dimension of A? Can you tell me what is the dimension of A? Can you tell me the dimension of A? F is equal to A into T means, what is A from that equation, appa?
F by T.
So force is M1 L1 T minus 2, time is T power 1. So M1 L1 T power minus 3. If I take T power 1 to the numerator, it becomes T power minus 1. So it becomes T power minus 3. So M1 L1 T power minus 3 is the dimensional formula for the constant A. Now, I will give one more equation. P plus A by V squared into V minus B is equal to R into T. Now, P represents pressure, V represents volume. Can you find the dimension of A and B? What is the dimensional formula for A and B? You know that if I want to subtract this V minus B means dimension of V and dimension of B must be same. What is the dimensional formula for volume? M0 L cube T0. M0 L cube T0. This is the dimensional formula for B. So what's the dimensional formula for B? M0 L cube T0. Similarly, if I want to find the dimensional formula for A means, I can equate the dimensional formula for pressure and the dimensional formula for A by V squared must be the same. Because if these two represents the same quantity, then only I can add this. So the dimensional formula for the pressure, the dimensional formula for A by V squared must be the same. So what is A from this equation? It is P into V square. What's the dimensional formula for pressure? It is M1 L minus 1, isn't it? Because pressure is defined as force by area. Force is M1 L1 T minus 2. Area is L power 2. If I take L power 2 to the numerator, it becomes L minus 2. So already L power 1 is there. So it becomes L power 1 minus 2, that is minus 1 into T power minus 2. So this is the dimensional formula for pressure, volume cube, volume squared. So L power 6. So M power 1, L power minus 1 plus 6 will be L power minus 5, T power 4. T power minus 2. So this is the dimensional formula for A. So if they have give any equations, you can write the dimensional formula for the constants. They may ask you to write the dimension of the constants by giving the equations like this. For 1 mark or 2 mark, they may ask this type of questions. Now, What are the main applications अथवा uses of the dimensional analysis? What are the main uses of the dimensional analysis? The first thing, we can check the correctness of the equation. We can check the correctness of the we can check the correctness of the equation. We can convert from one unit to another units, from one unit to another units, and we can derive the given quantity. To derive the given quantity in terms of other quantities, in terms of other quantities. So these are the three uses of the dimensional formula. So what are the three uses of the dimensional formula? We can check the correctness of the equation. We can convert from one system of units to other system of units. We can derive the equation in terms of other quantities. For example, let me take one by one. They may ask this for 5 marks, students. If I give the equation V is equal to V naught plus AT, I will ask you to check the correctness of this equation. Check the correctness of this equation. Check the correctness of this equation. To derive this or to check this correctness, first you write the dimensional formula for velocity. M0, L1, T minus 1. Write the dimensional formula for V naught, M naught, L1, T minus 1. Plus acceleration M0, L1, T minus 2 into the time T. Now M0, L1, T power minus 1, which is equal to M0, L1, T power minus 1 plus M0, L1, T power minus 2 plus 1 will be minus 1. Now please have a look on the dimensional formula for each term. Whatever the dimensional formula we got for each term, they are the same. If the dimension of each and every terms are same, then such an equation is said to be dimensionally correct. Dimensionally correct. So please remember, students, how to check the correctness of the equation. In order to check the correctness of the equation, you have to write the dimensional formula for all the terms. If the dimension is same for all the terms, then you can tell the given equation is dimensionally correct. You can take the second example. X is equal to V naught T minus AT squared. Check the correctness of this equation. Check the correctness of this equation. Now you write the dimensional formula for all these terms. For the distance, what is the dimensional formula? M0, L1, T0. For velocity, M0, L1, T minus 1 into time T minus, what's the dimensional formula for acceleration? M0, L1, T minus 2 into time squared, that is T power 2. So M0, L1, T power 0. Here M0, L1, T power minus 1 into T power 1, that is T power 0, minus M power 0, L power 1, L power 1, T power minus 2, T power plus 2, that is T power 0. Now please have the dimension of each term. The dimension of each term is the same. So the given equation is dimensionally correct. Students, actually this equation is physically wrong. Correct? No? Physically it is wrong. because there is no off term here. What's the standard equation? X is equal to V naught T plus what? Half AT squared alvendro. X is equal to V naught T plus half AT squared. But even if I not give the constant value, we can say that it is dimensionally correct. We can say it is dimensionally correct. Now, can you check the equation for this? V squared is equal to U squared plus 2AS. What's the dimensional formula for velocity? M0 L1 T power minus 1. We have whole squared equals to M0 L1 T power minus 1 whole square plus 2 into acceleration M0 L1 T minus 2 into the distance L. So M power 0, L power 1, L power 2, T power minus 2. Here M power 0, L power 1 into 2 will be 2, T power minus 2. Plus 2 into M power 0, L power 1 into L value will be L power 2, T power minus 2. So the dimension of each terms are the same. If the dimension of each terms are same, then you can say that it is dimensionally correct. So the given equation is dimensionally correct. So this is the first application of the dimensional analysis. Now, let us go to the conversion. Can you convert Newton to dynes? Now you know that for which quantity the Newton will be the unit. Newton is going to represent for which quantity apart? Newton is going to be used to represent the force, isn't it? So force is the quantity which is going to be measured in terms of newtons and in dynes. Write the dimensional formula for force. M1, L1, T minus 2. After writing the dimensional formula, write what is SI divided by CGS. Write what is SI divided by CGS. In SI system, mass is kg, length is meter, time is second. In CGS system, mass is gram, length is centimeter, time is second. So 1 kg will be how many grams? 1000 grams. 1 meter is how many centimeter? 100 centimeter. You can cancel this too. Divided by gram into centimeter. So centimeter, gram and gram will get cancelled out. So 10 power 3 into 10 power 2. Totally 5 zeros we have. 10 power 5. So in SI system, it is represented with Newton. In CGS, it is denoted with dynes. If I do the cross multiplication, what I am going to get? If I do the cross multiplication, I am going to get 1 Newton is equal to 10 power 5 dynes. So 1 Newton equals to how many dynes, students? 10 power 5 dynes. So similarly, here also you can convert joule to erg. How to convert joule into erg? You know that Joule is going to be measured for which quantity, students? For energy. Joule is going to be measured for energy. What's the dimensional formula for energy? M1 L2 T minus 2. M1 L2 T minus 2 is the dimensional formula for energy. Now, can you tell me what is SI divided by CGS? Mass is kg, length is meter, time is second. In CGS system, it is gram, centimeter squared, and second. So S power minus 2 will get cancelled out. 1 kg, how many grams? 1000 grams. 1 meter squared, how many centimeter? 100 centimeter. Since it has square, you can write it 2 times. Whole thing divided by gram. This centimeter squared can also be written for 2 times centimeter, centimeter. So this 2 centimeter will get cancelled out. This gram, even it is get cancelled out. So it is 10 power 7. Here we have 3 zeros. Here 2 zeros. Here 2 zeros. Totally it is 10 power 7. So in SI system, it is joule. In CGS system, it is erg. So if you do the cross multiplication, you can tell 1 joule equals 10 power 7 ergs. So this is how we are going to convert Newton to time and joule to erg. So this is the second application of dimensional analysis. Come to the third example. The third example, to derive the given physical quantity, we can derive the given physical quantity by using the method of the dimension. What's the question? They may ask the question like this. Derive an expression for the time period. Derive an expression for the time period, capital T, which depends on mass M, length L, and acceleration due to gravity G. So you have to derive an expression for time period of the simple pendulum, students. That simple time period of the simple pendulum depends on mass, length, and acceleration due to gravity. Now, first tell me for which quantity you have to derive the expression. We have to derive the expression for the time period. You keep that time period in the LHS. Then you write the proportionality of dependent factors. It depends on mass. It depends on length. It depends on gravity. Now you raise the unknowns for this, A, B, C. For the quantities in the right hand side, you have to raise the powers, A, B, C. Then T is equal to some constant K into M power A, L power B into G power C. You can call this equation as 1. After writing this equation, write the dimensional formula for all the quantities except this constant. What's the dimensional formula for time? M0, L0, T power 1. Neglect that constant K. What's the dimensional formula for mass? M power A. What's the dimensional formula for length? L power B. What's the dimensional formula for acceleration? It is L1 T minus 2 whole power C. So I have written the dimensional formula for all the quantities. Then M power 0, L power 0, T power 1, which is equal to M power A, L power B, L power C, T power minus 2C. Now, you can equate the powers here, students. What is M power here? 0. What is M power here? A. What is L power here? B and C. So B plus C is equal to 0. What is T power here? Minus 2C, that is equal to 1. So C is equal to minus 1 by 2. Therefore, B is equal to minus C. So B is equal to 1 by 2. So this are the three-dimensional, constants what we got. You can substitute this in equation 1, students. Put it in equation 1. So T is equal to K, M power 0, L power 1 by 2, G power minus 1 by 2. So T is equal to K, M power 0 is 1, L power of can be taken as root L, G power minus of can be taken as 1 by root G in the denominator. Or you can say T is equal to K into root of L by G. What is K represents here? K is a constant called 2 pi. So time period actually becomes 2 pi into root of L by G. Actually in the exam, even if you don't mention K, they will give the complete marks to students. No need to write the value of K here. No need to write the value of K here. Students, this question is also very important for quarterly test. Maybe if they are asking 5-mark derivation from units and dimension, means this is the only one derivation we have in this chapter. So they may ask. So after analyzing this dimensional analysis, you came to know that there are some limitations here. There are some limitations. What are the limitations of dimensional formula, students? Here we cannot determine the value of what? Constants. We can't determine the value of what? The constants. And also please remember, this is not applicable for trigonometric equations and also for exponential equations. These dimensions won't applicable for trigonometric and exponential equations. Please remember, these are the limitations of dimensional analysis. Now, they may put the question for 1 mark in MCQs to find the concept of the significant figures, students. You know that the significant figure is the accurate plus one uncertain digit. Accurate plus one uncertain digit is considered as a significant figure. Accurate digits plus one uncertain digit is called a significant figure. Students, if you want to know this exact meaning of significant figure, let us take this is the normal scale, okay? This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2. Okay. Now Now exactly I'm going to place the object here. Now can you tell me the length of this AB? Students, you have to answer this. Tell me the length of this AB. This is 1, right? This is 1.1. This is 1.2. This is 1.3. Then what is this? I mean to say that you can't tell exactly the third digit. You can tell up to this accurate. This is 1.2. It is 1.3. But the point B lies between these two. So whatever the digit is there in the third decimal point here, this is uncertain. You can't tell it is 1.23 or 1.24 or 1.25 or 1.26, whatever it is. But this 1.2 is accurate. This is uncertain. So this accurate digit plus this one uncertain digit is what we called as the significant figure. So what is significant figure? Accurate digit plus one uncertain digit you can consider. That gives the significant figure. So there are some basic rules here to tell the significant figures, students. Non-zero digits are significant. Non-zero digits are significant. So what is the significant figure for 2, 3, 4? 3. Just count what is the number of digits we have here. 3. So that is the significant figure. If you get a 0 between two non-zero digit, it is also a significant. I mean to say that 2034. What is the significant digit?
4.
Very good. 4. You have to consider the 0 as also a significant. If I consider the trailing zeros, recurring zeros or recurring zeros are not significant. Are not significant. 2000. Don't consider these trailing zeros as significant. You have to tell only one. So what is the significant figure for 2000?
1, sir.
1. But please remember, students, if I put a condition something like this, what is the significant figure for 2000 kg?
4.
Very good. 4. You have to consider these 3 zeros as a significant if I mention this unit. So if I mention with the unit, you have to consider the trailing zeros as significant. This is one special case. Please remember. If I put the condition like this 2.2000, in the decimal point if it occurs, these trailing zeros are also significant. In the decimal, if there are recurring zeros, the recurring zeros in the decimal is also a significant. So what is the significant figure for this?
5.
5. If zeros are like this in the decimal point, what is the significant figure for this?
3, sir.
Very good. 3. Remember, if the number is less than 1, the starting zeros before non-zero digit are not significant. If I write 1.004,
5.
5.
5.
These zeros are significant because this number is not less than 1. It is more than 1. Only in the case of less than 1, if you have a zeros before the first non-zero digit, they are considered as the not significant. Got it?
Yes, sir.
So only the thing here you have to be very careful. If you are expressing with unit or with some power like 2000 into 10 power 3, in this case you can write the significant figure as what? 4. If I not write any number or a unit, then you can tell the significant figure is only 1. So this is how we are going to analyze the concept of the significant figures in the concept of measuring the values. I hope you will study this significant figure even in chemistry, I think. So these are the concepts which you are going to learn in units and dimensions, students. If you have any doubt, you can ask in these chapters. Any doubts?
No, sir.
No, sir.
Okay. Sir, Prasanna, sir?
Good evening, sir.
Yeah, good evening. Sir, actually, I completed the